Today's lesson is on a review of linear equations. A linear function or a linear equation is represented by a straight line when graphed and represented in a equation where the variables have no whole number exponents higher than 1. So there's a couple different forms of the linear equation. We have standard form, slope-intercept, and point-slope form. So for the standard form, we have ax plus by equals c. And when is that useful? Well, this is useful if you're trying to find x-intercepts and y-intercepts. Those are pretty easy things to find in this form. It's also easy to type this form. The reason that is because a, b, and c are integers, meaning positive or negative whole numbers, and technically a needs to be positive. B and c can be negative or positive. So that's one form of a linear equation. The next form we're going to talk about is slope-intercept form, which is y equals mx plus b. This is probably one of the most popular ones. The reasons we like to use this one is because it's easy to graph. It's also easy to find the slope and the y-intercept from the equation, so you can find information straight from the equation and then you can graph it. This is also the form that a lot of your answers are going to be requested to be put in. And then the third one is point-slope form, y minus y1 equals m parentheses x minus x1. This is used for writing equations. So this one is easy to write equations with given information. Specifically, if you have a point and a slope, it's really easy to write an equation from point-slope form. So now we need to discuss what slope is. Slope is a number that describes the steepness of a line. Slope can also be considered as a rate of change of a line, meaning how far does it increase vertically versus how far does it increase horizontally, how much is it changing and in what direction, or how steep is the line. And then lastly, we use the letter m to represent slope. So let me go through a little example here. Let's say we have a point here, we'll call it x1, y1. And then I have a point over here, we'll call that x2, y2. And we have a line going through them. Okay, so clearly this line is going up and to the right, but we want to know at what rate is this going up and to the right. Well, if I take a look here at the first point and make a mark over here at y, that's going to be y1, and then if I drag another point over here, that's going to be y2. Okay, and the distance between y2 and y1 is going to be the vertical distance that this graph or this equation is increasing, okay, between point A and point B. So that distance that it traveled vertically is going to be y2 minus y1. You just take the top one minus the bottom one there, and then you should get that value. Horizontally, if I take my points, I have x1 right here, and over here I have x2. And if I'm thinking about what the distance between these 2 points horizontally, the horizontal distance, the way I can get that is I can just subtract x2 minus x1. So when I'm thinking about slope, slope is a measure of how steep the line is. So we can say that slope is change of y over change in x. That little delta, triangle, is the Greek letter delta for change of y over the change of x. So we're going to take the y distance, how far did it change vertically, which in my formula, that is going to be the red y2 minus y1 over the change in x. And what is the change in x? Well, that's the purple x2 minus x1. So this is the formula for slope. Another way you can think about that is rise over run. So rise over run just means how far did you go up vertically versus how far did you go horizontally. So this formula, specifically this one right here, is going to help us in some of the problems that we're going to be doing today. But rise over run is a shortcut if you just want to think about rise over run. That reminds you how far vertically divided by how far horizontally. Then there's a couple different types of slope I want to go through. So we have slopes that run like this, up and to the right. We have slopes that run down and to the right. We have slopes that are flat, a horizontal slope. And then we have slopes that are vertical. So if you're going up and to the right, we call this a positive slope. If you're going down and to the right, this is a negative slope. If you're going flat horizontally, that is a 0 slope. And if you're going up and down, that's an undefined slope. The way I remember undefined is you can't like stand on it. Like if you put a person on each of these, this person's going uphill. Positive is going uphill. If you put a person on this one, that's going downhill to the right. That's negative. If it's not going up or down, that's 0. But if you're got a person down here, they're not actually on the slope at all, aren't they? They're falling down straight because there's no actual place to stand. I know that's kind of silly, but that's how I remember that this is undefined. You can't even stand on this slope. You're going to fall down. I'm going to go ahead and erase those little guys there. All right, so on these example here, I want you to identify the following slopes. So you're just going to have to pick 2 points that you can see clearly on your graph. And we're going to count. So here I can count up 2. So my rise is 2 over the run 1, 2, 3, 4, 5, 6. So my slope is 2 rise over 6 run. Now 2 6 can reduce to 1/3. And so my slope is 1/3. So if I would have picked 2 different points, let's say if I picked that one and that one, which are a little bit closer together, I'm going up 1 and running 3. Notice it doesn't really matter which points you pick, you're still going to be able to reduce to the same slope. How about the next one? I can see this one really well, and I can see this one really well. You don't necessarily have to pick the x and y intercepts if it's not easy for you, but in these it seems pretty easy for me to see. So in this case I'm going down 1, 2, 3, 4. Okay, down. How far did you rise? Well, we rose a -4. The reason we rose negative is because we were going down, okay? And then to the right, I count 1, 2, 3, 4, 5, 6. Okay, so 4, 6 reduces to -2/3. Negative, does that look like it's going downhill? Sure it does. Now if I would have picked 2 different points, I still would have got the same answer. Down 2, right 3. Or I could have picked those same 2 points and run +3 and rows in -2, you're still going to get -2/3 no matter which side you use your little triangle on, the right side or the left side. It doesn't really matter. Now on this next problem, you can tell right now because this is a horizontal line, my slope is 0. But let's pretend for a moment that you forgot, okay? Let's say you're on a test and you totally forgot. If you take 2 points and you count how far did it rise from left to right? Well, 0. How far did it run? 1, 2, it ran 3. So it rose 0 to get from one point to the next, but it ran 3, and 0 divided by 3 is still 0. So if you can look at it and know it's 0, perfect. If you want to pick 2 points and figure out it's 0, that's also okay. Now this last example is a vertical line, so you could right now realize that your slope is undefined. And if you can see that, great. Let's pretend you can't for a moment. I'm going to pick 2 points. I just picked any 2 random points that I can see very clearly. To get from one point to the next, I'm going to rise 1, 2, 3, 4, 5. So I'm rising 5, and I'm running left to right, none. Well, if you take 5 divided by 0 in your calculator, you're getting an error because 5 things can't be divided into 0 groups. Think about it, if you have 5 pieces of candy, how are you going to take those 5 pieces of candy and divide them into 0 groups? Well, you can't. Even if you eat them, that's one group in your stomach. So 5 divided by 0 is undefined by definition, so therefore the slope is also undefined.